Welcome back, everyone. In this section, we're going to talk about compound interest. Recall that if you use simple interest, you're going to earn the same amount of money every year, and it's always based on the principal, the initial amount that you invested. Below is an example from the last section showing the amount of simple interest earned for the first 4 years if $600 is invested at a simple interest rate of 5%. So this just means we're going to earn 5% of $600 each year. So we own $30 every year. Compound interest accounts for the value earned when determining the interest. Accounts, savings accounts, loan accounts will compound at different time points, annually, quarterly, monthly, and the interest is then recalculated based on the current value of the account, based on the money that you earned plus whatever interest you'd earned up to that point. So this is going to allow you to make more money over time rather than the same amount of money each year. So if we invest that $600 at a rate of 5% and we recalculate the interest each year based on the amount in the account, we can determine then how much money we would have after 4 years. After the first year, it's still 5%, so this would still be $30, and this would be $630. 5% of 630, that's going to be 630 times 0.05, or $31.5. And if we add that to our total, that gives us $661.5. Now we do the same thing to find the next year's. 661.5 times 0.05 gives 33.08 for a total of 694.58. And then for the last year, 694.58 times 0.05, 34.73. And then if we add that to the total, 729.31. So unlike simple interest where you were just making $30 each year, with compound interest, that $30 increases each year. As more and more years go by, the total amount of interest earned is going to get bigger and bigger. So after many years, the difference between the two accounts would be much larger than about the $10 that it is now. If we want to determine the future value of some account where the interest is compounded, then we need to know how often the account is compounded. In the formula we use, we're going to represent the number of times the account is compounded by a lowercase n. In the previous example, we calculated the interest after every year. If you calculate the interest once per year and compound the account once per year, it's compounded annually. If you compound the account 4 times a year, then it's compounded quarterly, which is essentially every 3 months. You can also compound accounts monthly or daily. To determine the future value of an account, we just use this formula here, where P is the principal, R is the interest rate as a decimal, T is the term of the investment in years, and N is the number of times that the interest is compounded each year. So if we want to find the future value of our $600 investment at 5%, if it's compounded quarterly for 10 years, the future value is equal to P times 1 plus R over N to the power N times T. So that's $600, 1 plus 0.05 divided by 4 to the power of 4 times 10. Again, it's important to know what order you do this in your calculator. 0.05 divided by 4, 0.0125, 4 times 10 is 40. When you put this in your calculator, do the part in the parentheses first. That's 1.0125 to the 40th power. Now we want to raise that number to the 40th power. That gives you 1.64, let's say 3619, for a total of $986.17. So let's look at if we compounded the accounts daily and monthly, and we're just going to compare in terms of how much interest is earned in each case. So first we need the value when it's compounded monthly or daily. A equals 600, 1 plus 0.05 over 12. This would be monthly. 12 times 10. That's 600 times 1.004167 to the 120 power, and then multiply by 600, we get 988.21. For daily, same thing, we're just going to replace n with 365. That's 600 times 1.00013699. 3650. 365 times 10 is 3650. We raise it to the 3650 power. We get 600 times 1.64866. 989.20. So you can see from just the difference between the values compounded monthly and compounded daily that even if you compound the account daily, you only earn an extra $1 over 10 years. The total amount of interest earned, A minus P, for monthly, 988 minus 600 is going to give you 288.21. For daily, 289.20. 388 and 389. We want to find the interest on an investment of $75,000 that pays 4.5% compounded weekly for 8 years. So we assume there's 52 weeks in a year, then we can say n is equal to 52. Compounds 52 times each year. To find the interest that we'll pay on 4.5% compounded weekly for 8 years, we want to find the future value, and then we're just going to subtract the principal. So the future value is $75,000. 1 plus 0.045 is the interest rate, divided by 52, raised to the power of 52 times 8 for 8 years. That's 75,000. 0.045 divided by 52 plus 1, 1.000653 raised to the 52 times 8 is 416. Power, 75,000 times 1.000653 to the 416th power, 1.43306. If we multiply that by 75,000, 107,479.19. So $100,479. To find the interest is just the future value minus the principal. And so 107,479.19 minus 75,000. The interest earned on the account, 32,479.19. $32,000. The effective rate, or the effective interest rate, is just the simple interest rate you would yield from the same future value over 1 year as the given compound interest rate. All this means is that you're comparing the interest rate that's used to what would be the simple interest rate that would allow me to make that much money. In this case, sometimes the compound interest rate is known as the nominal rate. In order to calculate the effective interest rate, we just use this formula here. It's related to the interest rate and the number of times that the account is compounded. If we know the compound interest rate, we can figure out the effective rate. If a loan has a nominal interest rate of 4% and the interest is compounded weekly, what would be the effective interest rate? Compounded weekly, again, would mean n is equal to 52, and our nominal interest rate are 0.04. To find the effective interest rate, we have 1 plus r over n to the n power minus 1. So that's 1 plus 0.04 divided by 52 to the 52 power minus 1. 0.04 divided by 52 plus 1 gives you 1.00076923 to the 52 power minus 1. If we raise that to the 52 power, 1.04079 minus 1, 0.04079. Or an effective interest rate 0.041, or 4.1%. It's not that much different from the compound interest rate, the nominal rate, but it is different. It's important to be able to compare financial investments to figure out if you're going to make more money with one account, or to figure out if one account is going to cost you more money, if one loan will cost more than the other. So we want to know which savings account is a better investment, 6.2% compounded daily or 6.25% compounded semi-annually. We can compare these two using the effective interest rate. So if we calculate the effective interest rate for both, 1 plus r over n to the n minus 1. Well then for the first account, 1 plus 0.062 compounded daily, so we're going to divide that by 365, and then raise to the power of 365 minus 1. 0.062 divided by 365 plus 1 gives 1.00016986 to the 365 power minus 1, 0.0640, or 6.4%. For the second account, we have 6.25%, but it's only compounded semi-annually. That means n equals 2. So 0.0625 divided by 2, and then raised to the second power minus 1. 0.0625 divided by 2 plus 1. 1.03125 minus 1. That gives us 1.06347 minus 1. For an effective interest rate of 0.0635, or about 6.35%. So even though the second account has a higher interest rate because it's compounded less times, the effective interest rate is actually lower. So the first account, if you invest more money in that first account, you will make more money over time. If we allow an account to just compound over and over and over again, the number of times it's compounded just gets larger and larger and larger. We can essentially assume that the account is compounded at every instant that exists. And in that case, we say that the account is compounded continuously. In order to figure out the future value for an account that's compounded continuously, we just let n be a really, really large number, and we figure out what happens in the formula. If you do that, you find that 1 plus 1 over n, the n power, as n gets really, really big, approaches a value known as 2.71828, which is written as a lowercase e. And so this e is a number somewhat like pi. It's an irrational number, but it's always the same number every time. E is essentially just the future value of $1 invested at 100% interest for 1 year when you continuously compound the account. So we're going to use this new formula to figure out what would happen if an account was compounded continuously. So we want to find the future value of $5,000 after 20 years for an account that earns 4% interest compounded continuously, and then we're going to compare that to if it was compounded annually. So continuously, A equals P e to the r times t, and so that's 5,000 e to the power of 0.04 times 20. You're going to want to look for the e button on your calculator, or you can use 2.71828 to the 0.8 power. The e button is generally above the natural log or the ln button, if you're looking for that on your calculator. If we want to plug this in and multiply, remember do the exponent first and then multiply by 5,000. You get $11,127.70. So after 20 years, you have $11,000 if it's compounded continuously. If it's compounded annually, 1 plus r over n to the nt, well again, n is 1 here. So 5,000 times 1 plus 0.04 over 1 to the 1 times 8. That's 5,000. 1 plus 0.04 to the 8th power. 1.04 to the 8th power times 5,000. And we have an account balance of $68.42 0.85. So the difference here is significant. When you compound the accounts continuously, you nearly double your money over 20 years, more than double the interest that you earned. Suppose you invest $50,000 in two accounts. One earns 6% simple interest, the other earns 6% compounded continuously. Well, let's compare those after 10 years. Well, $50,000 is our principal. And the simple interest rate, 0.06. And we're talking about a time frame of 10 years. To find the interest on a simple interest account after 10 years, well, we just want to compare 50,000 times 0.06 times 10, right? P times R times T. This is from the last section. 50,000 times 0.06 times 10. And we find that the interest earned after 10 years is $30,000. And so the interest each year, in this case, would just be $3,000. For an account that's compounded continuously, if we want to find the interest, well, we can find the future value. P equals e to the r times t, or a equals p e to the rt. 50,000 e to the 0.06 times 10. And if we calculate that value, 91,105.94. To find the interest, we're just going to do the future value minus the principal. So if we subtract 50,000 from that, you're going to get 41,105.94. And so the amount of interest earned after 10 years on a simple interest account is only $30,000. You earn an extra $10,000 on the compounded continuously account. There are definite differences in these accounts, and so it's important to be able to understand which one's going to work out better for you. Finally, let's just practice one more and find the future value of a $40,000 investment with a 6.9% interest compounded continuously for 25 years. So again, the future value, A equals P e to the R times T. And so that's 40,000 times E, or 2.71828 to the power of 0.069 times 25. Well, that's 40,000 e to the 0.069 times 25, 1.725. If you plug that into your calculator, $224,500.84. Please let me know if you have any questions about this section.